Hello, everyone. Welcome to the Math Magician's Den. We're going to talk again today about implicit differentiation. And this time, my implicit differentiation is going to involve equations. The last video I talked about implicit differentiation, we did expressions. And remember, we're taking the derivative with respect to x on all these problems. Okay? So what's the derivative of x squared with respect to x? Well, that's just 2x. It's a simple power rule. But now this is where we have to be careful. When I do the derivative with respect to x of negative 2y cubed, you're going to bring the 3 out front and multiply, gives me a 6. You're going to subtract 1 from the exponent. Simple power rule like we always do. But what you have to realize, I have to multiply by the derivative of y, which is y prime. You have to treat it like a chain rule. Because for all we know, y could be a function of x. And chain rule says I got to multiply by its derivative. If I did the same thing with x and thought of this as a chain rule, well, the derivative of x is just, with respect to x, is just 1. So same thing with 4y. What's the derivative of 4y? Guys, the derivative of 4y would be 4 times the derivative of y, which is y prime. And again, what's the derivative of a constant? The derivative of a constant is 0. Now, how do I solve this for y prime? Now, obviously, I want the y prime terms on the same side. So I'm going to keep this 4 and this minus 6y squared. Both are multiplied by y prime. I'm going to keep those on the left-hand side, but what I'm going to do is I'm going to subtract that 2x to the other side because this doesn't have a y prime. Now, I'm going to factor out that y prime from those two terms, and I'm going to be left with 4 minus 6y squared. And knowing our rules for solving, if I want to try and solve for y prime, what I have to do, whatever is multiplied by y prime, I'm going to have to divide by that expression. And you'll notice here, I can reduce by 2. That would give me x. And sorry, I forgot a negative here. It would give me a negative x over 2 minus 3y squared. And that is the value for that's the expression for my y prime. Now, what does y prime represent? Y prime represents the slope of the tangent line. So let's take a look at this original graph. I've actually got it on Desmos, and this is a crazy graph. Now, let's say I wanted to find the x-intercept. You would set y equal to 0, and obviously these terms right here would drop out, and I would get x squared equals 2. And so the x-intercepts would be plus or minus radical 2. Now, if I want to look at those x-intercepts at plus or minus radical 2 comma 0, I could find the slope of the tangent line at both of those points. Okay? How would I do that? How would I find the slope? We're going to plug radical 2 in for x, so this would be negative radical 2 over 2 minus 3 times 0 squared. This would come out to be negative radical 2 over 2. That is the slope of the tangent line. So what I can do also is I can write, and this is for positive radical 2 over 2, I could write my tangent line, y minus 0 equals negative radical 2 over 2 times x minus that radical 2. This is the slope of the tangent line, negative radical 2 over 2, at the coordinate radical 2 comma 0, and that helped me write my tangent line. So let's give this a try. Let's try y equals, it would be negative radical 2 divided by 2, that's my slope, times x minus radical 2. You'll notice that does give me a tangent line at that x-intercept. The only thing that would change at the other x-intercept is the signs. It would be a positive radical 2 over 2, and this would be a plus radical 2 because it's plus or minus negative radical 2. So you notice we can still find equations of tangent lines, even on something that is not a function, using implicit differentiation. Let's go back to this other screen here, and let's see if we can do this next problem and figure out what the expression for my derivative should be. What is the derivative of y cubed? Well, it's 3y squared, but you got to multiply by y prime. What's the derivative of y squared? It would be 2y, but what's the derivative of y? It would be y prime. You'll notice every time I have a y, and I'm taking the derivative with respect to x, I got to put a y prime. This one's obvious. The derivative of negative 5y is negative 5 times the derivative of y, which is dy dx, or y prime. Now, when you have x squared, the derivative of x squared is just 2x, and the derivative of negative 4 is 0. Now, how do I solve this for y prime? Well, first thing I'm going to do is I'm going to add that 2x to the other side. I'm going to take this term because it doesn't have a y prime, put it on the other side. Now, we can do this all in one step. Take a look at all three of these terms. If you factor out the y prime, what is left? What am I going to divide by? You're going to divide by 3y squared plus 2y minus 5, and there is the expression for the slope of your tangent line. And here's what's crazy about this. You're not just going to use x values to find your slope. We need x and y values to find my slope. So if I was given a coordinate on my graph of this particular relation, I would need both the x and the y to find the slope of the tangent line. Let's try a few more here, and we're going to get a little bit more complicated. In fact, I'm going to start out with the easier one on this page. The easier one is the one with cosine. What is the derivative of cosine? Well, the derivative of cosine is negative sine of y. But what is the derivative of y? It's y prime. On the other side, what's the derivative of x squared? It is 2x. So in this case, how am I going to solve for y prime? Well, two things I could write. I could divide by the negative sine of y, and I could leave it written this way. There is my derivative. That would help me find the slope of the tangent line at any point on this curve. I'm thinking this would be negative 2x, and 1 over sine is cosecant of y. I could have written it that way as well. That's the expression for my derivative. This is how you would find the slope of the tangent line at any given point. Okay? So let's take a look at this other one. This other one is going to be a little bit more complicated. I have an expression raised to a power. How do I take the derivative of this expression raised to a power? I'm going to bring the power out front. That would give me 6. That expression would now be raised to the first power, but you have to multiply, chain rule, by the derivative of the inside, which would be derivative of x squared is 2x. The derivative of y squared would be 2y, and you guessed it, I need a y prime. Now this is already getting ugly. On the other side, I think of this as 100x times y. What's the derivative of 100x? It's 100. And I have to multiply that by y. Plus 100x, I have to multiply that by the derivative of y, which is y prime. Now what I need to do here is I need to actually solve this entire thing for y prime, which is going to get a little bit complicated. Now this is going to involve some algebra. If I multiply these two terms, I get 2x cubed, but when I multiply by 6, that's 12x cubed. The outer terms, multiplied by 6, it's going to give me 12x squared y prime. The inner terms, multiplied by 6, are going to give me 12xy squared. And the last terms are going to give me 12y cubed y prime. And obviously on the other side, I've already got that figured out. That's going to be 100y plus 100x y prime. That is not calculus. All I did was multiply it out. This is a lot of algebra we're doing here. Okay? So when I look at the algebra I need to do, I need to get all the y primes on the same side. So I've got this term, and this term all need to be, sorry, I apologize. Let's back up. I'm underlining the wrong terms. I got to get these three terms on the same side. So what I'm going to do here is I'm going to take that 12 x squared y and that 12 y cubed, and then I'm going to subtract the 100x all to the left-hand side because they all involve y prime. Everything else on the other side, this term, and this term, I've already got the 100y over there. I'd have to subtract the 12x cubed, and I'd have to subtract the 12xy squared. And again, that's all algebra. I'm just moving terms from side to side. How do you solve for y prime? Well, on the other side, I still have this 100y minus 12x cubed minus 12x y squared. And what am I going to divide by? I'm going to divide by everything that's multiplied by the y primes, because I'm going to take those y primes out of there and divide by 12x squared y plus 12y cubed minus 100x. And other than reducing by a factor of 4, this is my expression for my derivative. I would divide by 4 on every single term. And none of those are divided, or not all of those are divisible by x. Not all of those are divisible by y, but all of those are divisible by 4. This is literally the derivative of this expression. And again, if you wanted the slope of the tangent line, you'd have to use x's and y's. Now, one quick thing before I let you go, we're going to find the derivative of a circle. Yes, this x squared plus y squared equals 25 is the circle of radius 5 that's centered at the origin. And the derivative would be 2x plus 2y. And what's the derivative of y? You got it. The derivative of y is y prime, and the derivative of the 25 is going to be 0. Now, if I solve this for y prime, I would have to subtract the 2x, divide by 2y, and I would get y prime equals negative x over y. That is the derivative at any point on a circle, centered at the origin with a radius of 5. In fact, with any radius, actually, because the 25 essentially doesn't affect the derivative. Now, real quickly, we're going to try and do the second derivative. This is going to get crazy, because when I'm trying to do the second derivative, I'm going to have to take a quotient rule. The derivative of the top is negative 1 times the bottom minus the top, which is negative x, times the derivative of the bottom, which is actually y prime, all over the bottom squared, which is y squared. So this comes out to be negative y plus x times the derivative is negative x over y. And again, on the bottom, I've got y squared. Now, to make my life a lot easier here, we're going to do some simplifying. I'm going to multiply the entire top by y and the bottom by y. Here, I'd get negative y squared. Here, the y's would cancel. I'd get negative x squared. And on the bottom, I'd get y cubed, and that is essentially my second derivative, which would be fine. But watch this. If I take a negative out of the top, I get y squared plus x squared. You recognize that? X squared plus y squared, that's 25. The second derivative is negative 25 over y cubed. That's my second derivative for the circle. All right, guys, if you like this video, please hit the like button. If you want to subscribe, hit the subscribe button. I would appreciate that. I'll be posting more videos later.